get started with the lesson today. Now, what we're doing is continuing up what we started yesterday. And with radicals, solving radical equations, one of the things that I necessarily didn't state yesterday is that what's inside the radical can't be negative numbers, but we kind of already knew that. Now, it's not as big of a deal for these here, but it does come more into play when we talk about inequalities. We talk about inequalities later. But whenever we solve an equation with radicals, the first thing we need to do is get the radical by itself. If there's more than one, we try to even them out. As having two radicals on the same side isn't necessarily a bad thing. It just becomes very complicated very quick. So when we look at this here, if we can split those apart, it's going to make it a little bit easier to work with. So what I would do is add square root of x minus 3 to both sides, so that on one side, we're left with just the square root of 2x minus 5 is equal to 1 plus the square root of x minus 3. And once we get the square roots evened out, our next step was to put both sides to the nth power. In this case, the nth power is 2. Now for the left-hand side, the radical and square will cancel, leaving us with 2x minus 5. Now we do need to square the right-hand side, which unfortunately is not going to be just squaring the 1 and squaring the square root. We actually have to multiply this out. So we do get 2x minus 5. Here 1 times 1 is, well, 1. 1 times the square root of x minus 3 is just going to be plus the square root of x minus 3. Do the same thing. Square root of x minus 3 times 1 is just the square root of x minus 3. And lastly, the square root of x minus 3 times the square root of x minus 3 ends up being just x minus 3, because it would just be the square root of x minus 3 squared, and the square root and square would cancel. Now we don't necessarily need the parentheses here, because it would just be x minus 3. If the sign in front of it had been negative, then we do have to distribute that negative through. But we can leave it as just x minus 3. And the reason I do that is we can combine like terms. While the only x outside of a variable is just our 1x. However, our 1 and negative 3 are like terms, which gives us negative 2 plus. Our two radicals are the exact same, so we have two of them. 2 square roots of x minus 3. Questions on this so far? So, our step 3, which we didn't use yesterday, was if there are still radicals, repeat steps 1 and 2. We still have a radical. And our first step was to get the radical by itself. If there's more than one, even them out. We only got one, so we want to get it by itself. So the first thing we can do is subtract x from both sides. When we subtract the x from both sides, we get x minus 5 equals negative 2 plus 2 square root of x minus 3. Next thing we can do is add 2 to both sides. Minus x minus 3 is equal to 2 square root of x minus 3. Now at this point we could square it. There's nothing wrong with doing that. or we can divide by 2. I think it's going to be a little bit easier for us if we go on and just square both sides. Because on the left-hand side here, we're going to have x minus 3 times x minus 3. And on the right-hand side, we're squaring both terms. 2 squared would be 4, parentheses, square root of x minus 3 squared just becomes x minus 3. Any questions on this step? You do not have to write this. I'm just wanting to explain how we get to this here, squaring it, because it seems a little arbitrary. Why did we just square both terms on the right-hand side but not on the left? On the right-hand side, we are saying 2 times x minus 3 is being multiplied by itself. So we have this here. Now we can multiply, when we multiply 2 monomials, because it is a monomial, one term, we multiply the numbers in front first. So our 2 times 2 gives us 4. The square root of x minus 3 times square root of x minus 3 gives the square root of x minus 3 squared, which is just, do you all kind of see the difference? And the key, the big thing that really changes or is different between these two is that minus between the two terms. That's what throws everything off. And I just wanted to bring emphasis to that because it is something, especially in Algebra 2, students have a trouble seeing the difference between those two. And it's because of that minus between the two terms or plus between the two terms that we have to actually multiply it out. Now, if you do run out of space on your page, you can draw an arrow up and make a second column, because this is indeed getting to be a long process. On the left-hand side, we would have x squared minus 3x plus 9 if we multiply this out, because I think at this point we feel comfortable with doing these. On the other side, we can distribute the 4 and get 4x minus 12. I'm going to combine like terms. I'm just writing those down for reference for myself. The next thing we can do is get this thing equal to 0 so we can solve. I used red originally. We can minus 4x from both sides. Telling us that we have x squared minus 10x plus 9 is equal to negative 12. Now the last thing we need to do before checking is to solve this quadratic. Do we want to graph it, factor it, or quadratic formula? We can graph it, x squared minus 10x plus 21. Crosses at 2 nice places, and those 2 nice places are 3 and 7. So the two solutions for this are 3 and 7. And the last thing we need to do is actually check it back in the original problem just to make sure that it does work. So the first one I would check is 3. Now we could plug this all into a calculator. So we could say second square root of 2 times 3 minus 5 minus second square root of 3 minus 3 is 1. Look back over here. So this entire left side becomes 1. 1 is equal to 1. It works. Then we can do the same thing with 7. 2 times 7 minus 5 minus 7 minus 3 equals 1. So 7, and we get 1. They both work. So just as a heads up when I say check, because if it does say check on a test, check your answers for a certain set of problems on the test, this is all I'm looking for. That you plug the number back in and that it worked. And you might be thinking, well, how do I know for sure that you checked it? Well, if it's wrong and it actually didn't, if 3 was actually not a solution and we shouldn't get 1 equals 1 and you tell me 1 equals 1, it kind of tells me you didn't actually check it, if that makes sense.
Seniors at this time. Thank you.
We'll pause it.